All right, so we're going to go ahead and talk about friction and spring forces. Friction is a resistive force that opposes the motion or its tendency, okay? And spring forces involve a spring, which is a medium that has a specific atomic structure that can restore its shape if it's deformed. So to restore its shape, a spring exerts a restoring force, and that is proportional to and in the opposite direction in which it was stretched or compressed. And this is the idea of Hooke's law. And Hooke's law is a force F is equal to negative K, or the constant of proportionality, times X, which is the displacement of the spring, okay? K is also a measure of the spring's stiffness, okay? So we have examples here of this restoring force, F, okay? And so if we start, the system here is in equilibrium and we compress it, okay? Then there is a restoring force that will point in the opposite direction to which it was compressed. And in the other direction, if we have extended the spring, the restoring force will be in that opposite direction. Okay? All right. Here is a bit more on drawing free body diagrams that I mentioned before. We want to first sketch the object that's under consideration. Then we want to include all forces that act on the object and represent them as vectors. Then convert that into a detailed diagram that shows the x and y components of their given forces. And if there are two or more objects in the problem, draw separate free body diagrams for each object. Okay, so we have this process here. We start with this sled with some sort of force, okay, pulling force, and then we break that down into its x and y components here, okay? So let's go ahead and do an example of that. This is example 5.16. It states a block rests on a table as shown. A light rope is attached to it and runs over a pulley. The other end of the rope is attached to a second block. The two blocks are said to be coupled. Block M2 exerts a force due to its weight, which causes the system, two blocks and a string, to accelerate. Okay, so we have two different objects here. So what we'll do is we'll create two different free body diagrams for them. Okay, so if we have our M1 here, okay, we will have the weight due to gravity. So it's going to be weight 1, or M1G. Okay, then we have the normal force on that guy. And we also have our tension. Okay, so we have tension here. So this is for mass 1. For mass 2, we have the weight, again, due to gravity. So it's going to be M2 times G. And again, we will have tension, and that is equal to T. Okay, so these are our two free body diagrams of these two blocks on this pulley system. Okay, and it is, that's pretty much all this question was asking. So we have done this in the past a little bit, but I just wanted to show you another example of this, since this will be on your homework, and it probably will show up on an exam. Okay. All right, so this is the end of this section. If you have any questions, let me know. Email me, message me. I will be uploading these and updating you guys on any other labs or homeworks that you guys will have soon. All right, we will see you next time.